In today's episode, I'm going to be discussing the soybean industry and of soybeans' use throughout our food system. Let me just preface this podcast by saying that everyone's dietary choices are their own, and what you eat ought to be dictated by you and you only through informed decision making. I am not here to convince anyone that organic soy and its products, especially those made from whole beans, is not a viable and important source of nutrients for some people. Whether or not you vehemently believe your way of eating to be true, the purpose of this podcast is to inform the consumer on the current state of the soybean industry and to predispose them into making informed eating decisions. With that said, let's begin. Livestock are eating all of our food. There's a relatively newfound idea gaining traction in the environmental movement and beyond. It's calling for the removal of all livestock from our agricultural systems in an attempt to reduce carbon emissions as well as the quantity of land allocated to producing enough food for our world's growing population. Leaving out the fact that each year, for one reason or another, 370 pounds of food produced for every human on this planet is wasted and never actually makes it to their stomachs. The rationale to remove livestock from our food system has more holes in it than Louis C.K.'s famous novel Holes. However, let's first articulate the argument before we poke holes in it, of which even Stanley Yelnats would approve. Here's the argument. The quantity of macronutrients, so that's fat, carbohydrates, and protein, in grain and oilseeds, so think corn and soy, fed to an animal will never equal the amount of human edible food yielded from that animal in the form of meat, dairy, or eggs. This phenomenon is described in the scientific literature as the feed conversion ratio, FCR for short. So this is the quantity of feed input per unit output in the form of meat, dairy, and eggs. The FCR highly depends on the quality and digestibility of feed given to livestock. With soybean as feed, the FCR is low, about 2 to 1 for broiler chickens reared in an enclosed house, and denotes that the animal is efficient at turning feed into human edible food. If the FCR is high, so 10 to 1 for feeding soy to cattle, then it means that it takes 10 pounds of feed to convert into 1 pound of beef or dairy product fit for human consumption. Okay. Ultimately, this phenomenon has more to do with the fact that there is a loss of energy through metabolic processes, respiration as the example, when energy transfers from one trophic level to another. And so trophic levels can be explained by nature's hierarchy of consumption. So algae are eaten by plankton, which are eaten by small fish that are eaten by a larger fish. Through an agricultural lens, the sunlight is captured by grass that is eaten by the cow, which is eaten by us. So during each consumptive event, energy is lost from the system in two ways. First, from an organism metabolizing the energy they consumed, so through respiration, or two, from fungi and microbes decomposing parts of the organism that were not consumed by the organisms in the following trophic level. For example, when a cow does not consume all the grass out on pasture, microbes eventually decompose that grass and most of the energy is lost to the cow by way of energizing the microbial world. Even a plant does not harness all of the energy from the sun that strikes a leaf. In fact, the plant metabolizes half of all the energy it harnesses via photosynthesis by way of its respiration. Yes, plants do respire. The loss of total energy within an ecosystem from one trophic level to another is an inescapable aspect of life on this planet. Let us be thankful that plants can harness additional energy from the sun and that it finds its way to all other life on this planet. So the proposed argument is then to curtail feeding livestock a portion of the billions of pounds of grain we grow each year and feed it directly to humans. This call for industry-level disruption is supposedly in order to grow enough food for a large demanding population. In addition, this idea claims that we will actually use less acreage for food production because livestock require more land but produce less protein output per unit of land. Those espousing such naivety fail to recognize that for centuries, if not millennia, and right up until the invention of the Haber-Bosch process in the early 20th century, the two key practices for maintaining a cropland's fertility was the application of livestock manure onto arable crops and the use of a crop pasture rotation system. Of course, there are some losses that occur during the removal of nutrients from the land via animal products, but compared to the losses from crop removal, grazing livestock are actually considered nutrient cyclers and not nutrient removers. So the loss of nutrients from land under crop production is very profound, and so it's not surprising that more calories and protein, which are nitrogen-rich molecules, are produced on a per-acre basis from croplands than from grazing lands. By definition, non-arable land is marginal land that cannot be plowed or used to grow crops. However, it represents 2/3 of all agricultural land use around the globe. Generally speaking, the primary productivity occurring on marginal land, so that's tundra, desert, and mountains, pales in comparison to the productivity of nutrient-rich farmland with ample access to irrigation water. So of course, crop production on the more fertile lands will outcompete livestock in the production of protein on a per-acre basis. This is an apple to oranges comparison that can make even the most monkish of people want to pull their hair out. However, to deduce if any argument has merit, it is best to understand the underpinnings of both sides. So let us look at one specific oilseed crop we grow to feed both humans and livestock, and that is soybean. Soybean use throughout our food system. So Hannah Ritchie, a PhD data scientist out of Oxford University's Martin School, is one of the main proponents of this idea. She has published a number of articles on this topic, and one of these articles titled, "Is Our Appetite for Soy Driving Deforestation in the Amazon?" Hannah uses her data and statistical background to summarize how much soy we produce and its current use throughout our food system. Then she uses the data to make the case that soy food products, so that's tempeh, tofu, and soy milk, are not the main drivers of deforestation because so little production is used in the making of these products. So according to her data, these soy foods account for only 7% of global soy production, whereas livestock consumes 76%. Therefore, because animals are so poor at converting all this human edible food into animal products, then we should just eat all this soy instead. It will feed more people using less land. This is her argument, at least, and parroted by individuals both in the news and across governmental organizations. Aspects of Hannah's data are not incorrect. The data set she used comes from the United States Department of Agriculture's Production and Supply Distribution website. Here, the data only covers the quantity of soy produced globally and the imports and exports of soy for each producing country. She also claims that some of her numbers come from another dataset found at the Food Climate Resource Network, FCRN for short, but it's actually unclear how to find and access this data. For argument's sake, however, let's assume that all of her numbers are accurate and can be used for discussion. Then it's true. Livestock do eat 76% of all soybeans produced, and humans consume about 20% of them. However, this is not the end of the discussion. Even in her research, which is available on her website, ourworldindata.org, she reports that beef and dairy consume only 2% of all soy grown. So where is all that soy going if only small amounts are being consumed by humans and cattle? In order to fully answer this question, we must first explore how soy is grown and where it's used in our food system. Soy is grown in vast monocultures that require enormous amounts of chemical and industrial inputs for production, such as inorganic nitrogen fertilizer and herbicides, but this system is compromising the health of our agricultural soils, ecosystems, and us. In 1975, global soybean production was only around 50 million metric tons per year. In 2023 alone, 400 million metric tons were produced, an 800% increase. Today, roughly 95% of soy grown is genetically modified, strictly for the ability to spray herbicidal glyphosate, Monsanto's Roundup, onto fields. The patented seed is literally called Roundup Ready Soy, and boy does it get sprayed. Since its conception, the world has sprayed 9.5 million tons of glyphosate onto our lands. It does not necessarily increase crop yields for the farmer, it simply reduces the loss from weed competition. Moreover, soybean is in a classification of plants that can live in symbiosis with nitrogen-fixing bacteria, which are able to convert atmospheric nitrogen gas into plant-available forms. In part, they do this in exchange for plant-derived sugars the bacteria can use as an energy source. However, the use of glyphosate in soy production actually kills these bacteria on contact, thus destroying nature's little nitrogen factories, so to speak. This management system has led farmers to become increasingly reliant on the industrial and chemical industries and less reliant on natural biological processes for crop production. The use of glyphosate in the production of soy is also destroying our gut microbiomes. Monsanto claims that glyphosate is non-toxic to humans because human cells do not utilize the shikimate pathway in our metabolism. Plants, bacteria, and fungi, however, utilize this metabolic pathway for the production of aromatic amino acids, phenylalanine, tryptophan, and tyrosine. Tryptophan is actually the precursor to the neurotransmitter serotonin, which is considered the happiness and optimism molecule. Most people don't realize that 95% of total body serotonin is produced by bacteria in our gut. These bacteria, in fact, use the shikimate pathway for the ultimate production of serotonin, and glyphosate is killing our microbial happiness factories just as it's killing the nitrogen factories in our soils. Even more frightening is the knowledge that higher glyphosate levels found in GM soy feed, so that's between 1 and 15 milligrams per kilogram, negatively affect the reproductive fitness and growth rates of animals, despite those glyphosate levels being well below the United States regulatory maximum residue levels of glyphosate on crops at 40 milligrams per kilogram. Furthermore, the glyphosate residue levels in this soy are on orders of magnitude larger than maximum allowable levels in drinking water in the EU at 0.1 milligrams per liter. A liter is the same weight as a kilogram. In this 2015 paper, conducted by Mercura and colleagues in Norway, the researchers used soybean collected from a number of different GM soybean farms located throughout the state of Iowa. They test 8 different soy meal diets, each with increasing concentrations of glyphosate residue. And what they found is that increased levels strongly correlated with higher mortality, reduced growth, delayed maturity, and reduced total offspring in the test animal Daphnia magna. These are a species of plankton, of which are the foundational food source for many different ecosystems throughout the world. To summarize, the production of GM soy, whether its final destination is in the stomachs of livestock or ours, has compromised the health of many different planetary organisms and the sustainability of our agroecological systems. Cows aren't eating all of our soy. The common misconception is that cows are consuming most of the soybean grown. According to the USDA dataset Hannah Ritchie uses in her work, global soybean production averaged 350 million metric tons per year between the years 2017 and 2019. About 4% was used in industrial applications like biofuel and lubricant production. Only 7% of these whole soybeans were fed directly to all forms of livestock. Perhaps the most alarming statistic is that 86% of soybean produced is actually shipped straight to industrial processing plants to turn the beans into human edible vegetable oil. That means that over 8 out of 10 beans are grown for the manufacturing of soybean oil, but only 2 out of 10 beans end up as food for humans. How on earth does this math pan out? Where is all that soy going? So the processing of soy into oil is a multi-step process that requires an extremely fine level of detail to keep toxins within safe limits to humans. It requires heavy industrial and chemical inputs. It is an energy-intensive process and yet only produces a small amount of food fit for humans. So the process starts by removing the hull, which is the fiber of the bean, before it's rolled into flakes and soaked in a chemical solvent, hexane. Hexane is derived from crude oil. The flakes then undergo a distillation process to remove the hexane using yet another fossil fuel-based product, mineral oil. Regulatory frameworks require the use of food-grade hexane in mineral oil, but ultimately the residue levels of these compounds in both soybean oil and its byproduct soybean meal is entirely dependent on the integrity of the hexane and mineral oil recovery systems in place at these industrial plants. This oil extraction process only yields 20% of the soybean's original weight in the form of oil and produces an enormous amount of a byproduct called soybean meal. The weight of this byproduct actually represents about 70% of total global soybean production. Soybean meal is actually void of fat but rich in protein and carbohydrates. It then undergoes further processing to become either soy flour for human consumption or for livestock feed, representing 3 and 97% of soybean meal produced respectively. This byproduct right here is what these proponents of removing livestock from our food system are asking us to eat. So who is eating all of our soy? Hannah is correct in saying that 76% of soy is fed to animals, but this is where the confusion and the insidious nature of this argument begins. First of all, manipulating statistics to confirm one's bias is a great way to rally a bunch of people with collectively primed ears behind a cause, and this is exactly what I believe Hannah to be doing. The fact remains that 86% of all soy grown is for the production of oil, which is for the strict purpose of producing an ingredient found in thousands of products across our supermarket shelves. It's not our fault. It's certainly not the livestock's fault. This process is extremely wasteful and produces hundreds of millions of tons of unwanted waste each year. Second of all, Hannah and other proponents of removing livestock from our lands conveniently leave out of the general conversation which animals are eating this soy and extrapolate this metric as rationale for removing livestock from our cattle from our lands. 97% of this soybean meal is fed to monogastric animals like chickens, pigs, and fish. Only 3% is fed to cattle. In fact, according to Ann Motet's research at the United Nations Food and Agriculture Organization, soybean cakes make up only half of 1% of total ruminant feed intake. Comparatively, soybean cakes alone make up 15% of monogastric feed. Cattle are not eating all of our soy. Chickens and pigs are. Monogastric animals such as chickens and pigs, so mono meaning one and gastric meaning stomach, one stomach, cannot readily source energy from human inedible foods such as grass, leaves, and crop residue. They only have one stomach, and the stomach simply hasn't evolved to do so. If you take a look at Figure 2, which you will see is that roughage makes up 3.5% of total monogastric feed rations. However, soybean cakes and grains make up 71% of their entire diet. 2 out of every 3 mouthfuls in a monogastric's diet consumes human edible food. Comparatively, ruminant digestive systems have evolved for 50 million years to be able to source energy from roughage like grass, leaves, and plant residue. Ruminants are mammals with multi-chambered stomachs that source energy from fermenting their foods. They turn human inedible feed into human edible food. If you again look at Figure 2, soybean cakes and grains make up only 5% of a cow's feed ration around the world. On the other hand, roughage makes up 90% of a cow's diet. Only 1 out of every 20 mouthfuls in a ruminant's diet is filled with human edible food. If we refocus and take a look at land use for the production of cereal grains for the different livestock sectors, monogastric animals take the soybean cake. 2 out of every 3 acres of land allocated to producing grain for livestock is for the monogastric sector. It will then come as no surprise that pig and poultry production are the fastest growing sectors of the livestock industry. The poultry industry has increased, get this, 250% since 1990, and the pig industry has increased by 14% since the same year. Comparatively, the global cattle population of around 1 billion head hasn't changed since 1975. Hannah and others need to stop lumping cattle into the argument that livestock are eating all of our food. It's almost exclusively the monogastric livestock sector that is consuming all this soy. These proponents also need to think more critically about both the quality of this food and the way we grow it. On a personal note, and to date, I have never heard these proponents discuss the measurable destruction of our agroecological systems that has occurred through the production of GM soy. So this begs the question, why is our livestock consuming so much soy? As of early February 2024, the current wholesale commodity price for soybean meal is 23.8 cents per pound. This byproduct of oil production is a material that offers little economic value other than as livestock feed. No human wants to eat it. Comparatively, the current wholesale price for chicken meat is 74.2 cents per pound, triple that of soybean meal. Therefore, using the aforementioned feed conversion ratio of 2-to-1 for chickens fed soy, a keen business owner can turn 47 cents of feed into 74 cents of meat. The use of soybean meal for chicken feed is an economically viable use of an otherwise valueless byproduct of soybean oil production. Which came first, increasing soybean production for processing into oil for humans, or the use of its byproduct for livestock feed? It's incredibly difficult to parse out which was the main driver for this soybean boom. What is definite is that whether our mouths or the chickens are awaiting feed at the trough, Monsanto rakes in the cash. The more soybean produced means more profit from their patents. It is now clear that this has transpired since the invention of genetically modified soybean. Up until 2018, when Monsanto sold to Bayer for $63 billion, Monsanto owned as much as 80% of all the genetically modified seeds planted. To better illustrate the process of events since this sad day of the early 90s, we need to look at a brief history of genetically modified soybean since 1994 and its meteoric rise in cultivation. So in 1994, GM soy was first approved for commercial use in the United States, and since then, global soy production has increased by 310%. In 1996, Monsanto launched their first soybean patent in the United States. Its use quickly spread around the globe. In 1999, even the United Nations approved its use. In 2014, Monsanto's patent expired, and we saw a 30% increase in global production over the next few years. It became legal for other companies and farmers to use the patent and to save seed. In 2023, 100 million hectares, or about 10% of global arable land, were planted with monoculture soy and sprayed with hundreds of millions of pounds of the toxic herbicide glyphosate. Maybe, just maybe, the only reason why the livestock industry is consuming so much soy is because the agricultural industry has become co-opted by the giant corporate conglomerates of the processing and chemical industries. No one can patent nature, but they can patent genetically modified seed. And for 20 years following patent creation, it is highly illegal for farmers or other businesses to save that seed to plant the following year. So the more of your patented seeds you have farmers planting, the more money you make. We don't need 100 million hectares of land planted in soy. The industry is propped up by the chemical and processing industries to turn a profit. Unfortunately, this series of events has both destroyed the resiliency of our agricultural systems and of our farming communities. It is a house of cards just waiting for a strong wind. This highly processed vegetable oil and soybean meal is the supposed food that a growing minority of the population wants us to eat instead of animal products. Begrudgingly, these people classify these products as edible, and now, every single year, 242 million metric tons of soybean meal, the equivalent of 70 pounds for every man, woman, and child on Earth, is produced annually. I don't know about all of you, but I'll let Hannah Ritchie and others consume my 70-pound share of this Soylent Green. Have at it. All right, the 30,000-foot view. To defend this poor plant's reputation, of which I've picked on for the length of this article, let me talk about the benefits of this food crop. Growing organic soybean for the production of naturally fermented soy food products, so think tempeh, tofu, soy sauce, tamari, etc., has been an integral part of many different cultures' food systems for millennia. Soy itself is filled with both macro and micronutrients and absolutely can be a part of a healthy diet for many people. The argument presented in this podcast is not to claim that organic, non-GMO soy, grown in proper crop rotations and void of glyphosate, should not be part of our food system. The argument is that this newfound and now predominant industrial method of production is the soy-fed elephant in the room. So let's take a giant step back and look at this whole picture from the 30,000-foot view. Perhaps our culture needs to think more critically on whether we should even be producing this much soy in the first place. Should we really allocate 10% of all arable land into genetically modified soybean production and spray millions of acres of this land with toxic chemicals? Would you rather consume this soybean meal, a product of heavy industry, or would you rather consume organic food products that are more in harmony with nature and its carbon cycle? Pastured beef and dairy, as well as organically grown soy, can and must be a part of our diverse, resilient food system well into the future. In the end, you, the consumer, needs to vote with your dollar. If you care about any of this, challenge yourself and stop consuming processed soy. Instead, if you want soy to be a part of your diet, eat its fermented forms and have it grown organically. USDA organic foods cannot use genetically modified seeds and cannot be sprayed with glyphosate. If you don't want to eat soy altogether and don't want to contribute to the production of GM soy for livestock feed, of which is destroying our arable cropland and our gut microbiome, find a local farmer that raises their animals out on pasture or that only feeds organic soy and corn to their livestock. Know your farmer.